With this video, we're going to go through the entire lesson of arithmetic sequences. So it's kind of a lengthy video, but it'll go through all the different scenarios, give you lots of chances, lots of opportunities, I should say, to practice working with arithmetic sequences. So the objectives of this video are going to be, hopefully by the end of this, you'll learn what an arithmetic sequence is, the basic generic formula for arithmetic sequences, as well as trying to calculate an nth term. And this is some future term or some term in a sequence, basically. The reason why I like this particular lesson is because it helps me calculate how much money I'm going to make in the future. I can kind of plan to say, okay, well, if I continue to get raises at this rate, how much money will I have in the future? So let's get started on this. An arithmetic sequence, a big thing that we need to identify here is they have what they call a common difference. In other words, it always increases or decreases by the exact same number on every one of these numbers. Each one of the terms either goes up or goes down by the exact same amount. And let's kind of talk about that just a little bit. Geometric sequence is that they're being multiplied by some factor. With an arithmetic sequence, which is what we're talking about now, it's being added or subtracted by the exact same number. All right. So the difference between the term and a preceding term is what we call a common difference. Okay, now it's kind of fancy, but let's talk about this. Let's see, between negative 42 and negative 36, there are 6 units here. So between these two, there are 6. If we have that same amount all the way through, then this one is an arithmetic sequence. So let's look. The difference between negative 36 and negative 30 is 6. And same thing between negative 30, negative 24 is 6, and negative 24 and negative 18 is 6. So the common difference here is 6. And the way that we'll represent this in our formula is just D. D meaning difference. The difference is 6, and it's a positive 6. Because as this sequence progresses, every one of these numbers increase by a digit of 6. And it's a positive 6. Okay. So let's get a little bit of practice on this. We've got this one. This is a group or a data set. We're trying to determine if this one is an arithmetic sequence or not. So we have to find the common difference. And let's look at this. We've got negative 5 to negative 3. That would be a difference of positive 2. Between negative 3 and negative 1 would be a difference of positive 2. Negative 1 and 1 is a difference of positive 2. So it looks like, yes, indeed, this one is a sequence. And the common difference in this case would be 2 and positive 2. Let's look at another scenario here. And this one we start with a larger number. We've got 21, and then it goes down to 14. And with sequences, they can go up or down. It really doesn't matter. What we're concerned about is that they go up or down by the same rate, okay? So from 21 to 14, that would be a difference of negative 7. From 14 to 7 would be negative 7. 7 to 0 is negative 7. So yes, this one does look like it is a sequence, the difference being negative 7. Here we've got one, we go from 4 to 6. The difference between 4 to 6 is 2 units. From 6 to 9 is 3 units. So those two do not have the same difference between them. So this one is not an arithmetic sequence, not at all. This one here, we go from 5 to 2, which is negative 3, and then from 2 to 7, which is a positive 5. So we automatically know right there, after those two, that this one is not an arithmetic sequence at all. Remember, it has to have the same amount that we're either adding or subtracting every single time. All right, so let's look at where this formula comes from. And this kind of helps just to kind of know the why behind it all. If you want to just go right to the formula, this will take probably, I don't know, a minute or two to go through. You can just fast forward a little bit if you want to, but the first term in arithmetic sequence, this is important no matter what, is it's labeled as A of 1. Okay, and so when you see this label here, this is going to be important. We'll use this with our formula. That means the first term of the sequence. Well, in order to get the second term of the sequence, what we need to do is take A of 1 and add the difference, whatever the difference is. If it's a positive 6, for instance, if A of 1 was 6 and the difference were 2, 6 plus 2 would give me 8. That would be my second term of the sequence. Okay, so all we're doing is we're taking the first term, adding whatever the difference was. So for the third term, we're going to take the first term, add the difference, and add the difference again, because it's going to have, this is your first term, then we add the difference to that one, and we add one more difference on as well to get to the third term. Well, when we're doing this, D plus D, we know this. These are like terms, we can combine them, that's just plain old 2D. So for the fourth term, it's really going to be A plus 1 plus 3D. Okay, it's always going to be 1 less than what's right here. And so we will represent this in our formula as n. We don't know what this number will be, so we just label it n. And this one right here is always going to be whatever this number is minus 1. So our formula here, and this is our arithmetic sequence formula that we'll use all the time. We've got whatever this n value is here. This number right here is just n minus 1, whatever that number is. Whatever this number is, minus 1. And so this is the one that we're going to use quite a bit, this one here in blue. So that would be a good one to put down in your notes. So here, this page right here is be the one that I would put in my notes. Write down each one of this. This is just the nth term, whatever this term is going to be in the future. The first term, this is important. The term number, as for instance, if this was a of 36, we're looking at the 36th term of this sequence. D is important. It's a common difference, and that comes right here at the end. Okay. All right, so let's get a little bit of work with these. I've got this sequence right here. First thing that we want to try to do is find the common difference. To do that, we just look at what the difference is between these two. I've got a -7 and a -3. That looks like it went up 4 units. -3 to 1 went up 4 units. 4 units, 4. Okay, so we're good. So the difference in this case is going to be 4. Now, sometimes I will ask you to find the next 3 terms of the sequence, and all we're really going to do to find that is we're going to add 4 to 9. That would give me 13. Then we add 4 to 13. That would give me 17. And 4 to 17, which would give me 21. That's where this comes in handy, is because we can just add it to each one. So those are the next 3 terms in the sequence. Now, what if I asked to find the 23rd term in this sequence? So this is a of 23. 23rd term, well, we can continually just add this on and keep track of it every time. I can write like a little number under each one of them. This would be number 6, this would be number 7, this would be number 8, but that gets kind of tedious. There's a much, much faster way to do it, and that is using our arithmetic sequence formula. This is a very, very handy formula. Let's start plugging in information that we know. We are looking for a of 23, so I'm going to plug that in right here. We don't know what a of 23 is yet. I say that I'm going to get a little ahead of myself. We need to fill in what we know here. A of 1, this is the first term of the sequence, which is -7. Okay, so -7 here. Then we can we know what the difference is 4. We already identified that. Finally, we're looking for the 23rd term of this sequence. So now that we know that, we can start filling in stuff. A of 23, this means we're looking for the 23rd term. A of 1, we know what that is. It's -7. So we're going to write that in right over here. Let's see, n, we know what n is. N is 23. It's our 23rd term. You'll notice that this number and this number will be the exact same. So you'll see that as I type it in here. 23 and 23, these two numbers should always be the same here. And then finally we have our d, which is 4. Our difference is 4. Now all we really need to do is to simplify the right-hand side. So we've got -7 plus 23 minus 1 times 4. And technically speaking, if you wanted to, you could just plug this right-hand side into your calculator just like you see it here, and it will spit out the answer for you, which would be nice. All right, but I'm going to do this one the long way. Using my order of operations, I do the parentheses first. So I go 23 minus 1, which would give me 22. Now I've got multiplication next. 22 times 4 is 88. I've got 88 -7 plus 88 would give me 81. So my 23rd term of this sequence would be 81. And that's much faster than trying to write down each one of these and trying to label it underneath each one and continually add 4 to each one. This is a much, much more efficient way to do this. Okay, so let's get a little bit of practice on this. Here are 2 problems, and these are just like the ones that we just did. So if you need to, go back and push pause on the video and you can kind of mimic what's on here. But I'd like you to try these. So take out a piece of paper and attempt both of these. Push pause on the video now. After you've obtained your answers, you can come back and push play. Check your answers on both of these. So we have one in which the difference is actually a negative number. This one goes down by 7 units every single time, so our d is -7. If you're going to do this one and you're trying to type this one into your calculator, make sure that you have parentheses around here. Otherwise, the calculator's going to go, okay, it's 39 minus 1 minus 7. So just make sure you've got parentheses there and you'll be fine. All right, I would like you to try these 2. We've done both of these similar ones. Try these right now. Push pause on the video. After you've obtained your answers, come back and push play to check them. Check your answers here. So this one should have been fairly easy. You could see that it is going down by 9 units every single time. So all we need to do is keep going down by 9 units for the next 3. And those would be our answers on this. This one we're just kind of plugging in information that we know. It looks like it's going up by 10. My difference is 10. And my first term in the sequence is 8. We're just plugging this in and simplifying what's on the right-hand side. Notice on this one I did not use parentheses. You can, if you want to get in the habit of just using parentheses all the time, like similar to what I've got right here, that would work just fine. So if you want to, you can use it all the time. You'll always get the right answer that way. Okay, so we've got this one, and we're looking at it right here, and it goes 1 to 6, so we know what our common difference is. At least between these two is 5, and from 6 to 11 is 5, and from 11 to 16 that's 5. So all of these are going to have the common difference of 5. And that's really helpful to know because that's going to be a key component of our formula. So now we're asked to find the formula. So remember, our first term and our difference are going to be our keys here. This is the generic formula for an arithmetic sequence. The first term, a of 1, that's our first term in our sequence, which is 1. And our difference is 5. So now we're just going to plug that in. The first term is 1, and n minus 1, we just remain that because we're trying to find the formula that works for this entire sequence. Later on we can plug in, a of 162, and we can find the 162nd term of that sequence. And finally we have the difference. The difference goes at the end, and that's 5. And again, if you want to put parentheses right here, that's not a problem at all. So in fact, I would recommend that. That might make it a little bit easier for you. All right. Now I'd like you to try these two. Push pause on the video now. I'd like you to try to see if you can obtain the correct answer. After you work through the solution and you obtain an answer, come back and push play. Check your answers here. Okay, again, the first term in the sequence is 37. The difference here is we're going up by 4 units every single time, so that's going to be our 4 here. And this one, we found that the difference was -7. It goes down by 7 every single time. And we're asked to find the 39th term of that sequence. That'd be pretty tedious if you had to continually count it all out. It took up a lot of paper, so this is definitely a time saver. All right, so we'll get to a little bit more practice on this. Push pause on the video now. After you've obtained your answer, come back and push play. Check your answers here. Key component here is you're going to need to make sure you have the parentheses around this one. Okay, now this gets a little bit confusing at times because from here to here is definitely -100. From here to here is definitely -100. And this doesn't feel like it is because all of these have 72 at the end. This one doesn't. But remember, we're crossing 0, so that's why it's a little bit weird. If you did 28 minus 72, you'd see that there is a difference here. There are 100 units between these two numbers. Okay, this one's a little bit of a challenge. We're not given the first term of the sequence. We're not given a sequence at all, matter of fact. All we're given is a random term. The 16th term in the sequence is 91. And the difference is 4. We're looking for the 30th term in this sequence. We can continually add 4 to it each time until we reach 30. That is one method. It's not a very efficient method, though. So let's see if we can do this one using our formula. So here is our generic formula for arithmetic sequences. And again, we're going to be using this one quite a bit. So this is definitely one to commit to memory and make your life a lot easier. It won't be bad after you do this several times, but it's just a little daunting at first. So we've got this one in right now. All we're really going to do is start plugging in information that we know. We don't know the first term of the sequence, and that's usually what we have. That makes it really nice, but we don't have that in this case. But we do know the 16th term of the sequence is 91. Okay, so I can plug that in. 16th term, a of n, so a of 16 in other words, is 91. That's going to be nice to know. Okay, and then we plug that one in. We've got a of 1 we don't know, so that's just going to be a of 1. Plus n, well we know n is 16 in this case. If a of 16 is 91 here, n value here is going to have to be 16, so I can fill that in. And the difference, of course, we know the difference is 4. So we fill that in. Now what we're going to do is we're actually going to solve this one for a of 1. I'm going to try to get this a of 1 all by itself. That will help me because then I can have my sequence. I've already got my difference. As soon as I can find the first term, I'm good to go. Okay, so the way we'll do this is what's over here on the far right-hand side. We're going to start simplifying that. 16 minus 1 is 15. 15 times 4 is 60. Now all I need to do is subtract 60 from both sides. and I'll find out what A of 1 is. Well, 60 minus 60 is 0. 91 minus 60 would give me 31. So that's really helpful. Now I can take that and I can plug it right in for my sequence. This is my formula for this specific sequence. It's got a difference of 4, and we know that the first term of this sequence is 31. Well, why that becomes important is because I'm trying to find A of 30. So now what I can do with this formula found now, I can just plug in 30 right here for this n and this n and simplify it. So I plug in 30 in both places because we're looking for the 30th term. Then I simplify what's on the right-hand side. 30 minus 1 is 29. 29 times 4 plus 31 would give me 147. So it seems like a lot of work at first, only because you're not used to doing this one. If you do this process a couple times, this is going to be a major time saver. So we'll give you lots of chances to practice right now. This is using the exact same method that we just did. So I'd like you to push pause on the video now. If you need to, you can just rewind just a little bit to see how I did the last one, and just kind of mimic it right now. That's all we're really trying to do. Push pause now. After you've obtained your answer, come back and push play. Check your answers here. Okay, so that was, especially for the first time, that should be a good challenge for you. As we do these a little bit more, it will become easier. I want you to try these two here. Push pause on the video now. After you obtain your answers, come back and push play. This first one here should have been very, very easy. We already had the formula. All we're doing is plugging in 38 for both ends, simplifying what's on the right-hand side. That one should have been fairly easy. This one, hopefully it's starting to come a little bit easier for you. More practice will help more than anything on this. All right, push pause on the video now. Work through these two problems here. Then after you obtain an answer, come back and push play. Check your answers. Both of these were actually fairly easy, which makes it nice. As long as you can identify what the common difference is, you can do both of those very, very easily. This is kind of a real-life scenario. If you're hired on as an engineer, you end up having a starting salary, let's say, of $45,000. And what you know is that your company's promised to raise your salary, give you a raise of $3,000 a year. So we're trying to determine what your salary will be at the beginning of the 26th year of employment. So let's say you've been working for this company for 26 years. You continually receive this $3,000 salary. So the first thing you're going to need to do here is to set up your formula. After you set up your formula, you can plug in 26 for n. That's my hint. So push pause on the video now. Go through, obtain your answer. After you've obtained your answer, come back and push play. Check your answers here. 120,000 is what you should have obtained for your salary on the 26th year. Well, this will conclude this video. If you need to, you can go back in and watch it a couple more times. I also have very specific videos on very specific types of problems. You can look on my YouTube channel if you want for more specific videos. But anyway, hopefully this helped a little bit.